press the bell icon on the YouTube app and never miss another update.
Hello everyone. So today start with the last concept in case of this surface chemistry, that is about emulsions. Okay, so if you take these emulsions, as it is I can say is a corona year, so emulsions is not there for your theory part, but it will come in the competitives. Okay, so you should know about the emulsion, which is a very small concept. So if you take emulsions, so I already discussed in case of different types of colloids that we have discussed depending upon the disperse phase and dispersion medium, right. So there were the earlier classification what we have done. So there I told that these emulsions are nothing but the colloidal solutions where both the dispersion phase as well as the dispersion medium is in the solution state. Okay, so what we can say the definition for this one, the type of colloidal system, in which both okay, dispersion medium and dispersed phase are in liquid state. Such a type of colloidal systems are called as what? The emulsions. Such a type of colloidal systems are called as the emulsions. So here you can prepare these emulsions by mixing any two immiscible liquids, or you can say partially miscible liquids. So here you know that immiscible means they are not mixing with each other. Is that clear? They are not forming a homogeneous mixture. If you mix them, they form the two different layers. Such type of liquids you have to use for the preparation of these emulsions. So what they are saying, emulsions, they can be prepared. Okay, so they can be prepared by mixing. Yes, ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ? By mixing two immiscible, okay, or you can say partially miscible liquids. So this is how you can prepare the what? Emulsions. So these emulsions we are going to see in our day-to-day life also. If I give the examples now, then you can understand what are emulsions. So understood the definitions. So they are the colloidal systems where the dispersion phase as well as the dispersion medium both are in the what? Liquid state. Both of them are in the liquid state, and then they can be prepared by just mixing the two immiscible liquids, or you can say the two partially miscible liquids. Okay, so here you can give that example. You can have, say for example, if you mix oil with water. Okay, oil with water. So you know that water is a polar solvent, whereas if you take the oil, it is non-polar in nature, right. So that's why if you mix oil with the water, it will form into a different. You can easily distinguish between the oil and the water. But if you take say for example if you have NaCl and if you add to water, you cannot easily distinguish. Small amount of NaCl if you take and if you add to the water, you cannot easily distinguish between what we can say the salt and the water. But here in case of this emulsion, you can easily distinguish between the two liquids which are mixed during their preparation, right. So that like that we are that is done nothing but the emulsions. Okay, so here these emulsions are of two types. If you take the types of emulsions, they are of two types. The first type is water in oil. Okay, if you take a small amount of water and if you add that one to the large amount of water. So how we can say that one? Water in oil or water in oil. Okay, first type is water in oil. Okay, so how you can represent this one? So water, that is W in oil, like that you can write. So there is an interface between these two that we can represent here. Okay, so here which is the dispersion medium and which is the dispersive phase. So in means that is nothing but the medium, and what you are going to add, that will become the dispersive phase. Okay, so here what we can say, so water is dispersed, water is dispersed in oil, in oil. So what we can say, so water is a dispersed phase, and what about the oil? Oil act as a dispersion medium. So if you get the MCQs, you can easily write this one. Okay, because it is water in oil. Water, you have added small amount of water. If you have added to what? The oil. Okay, so if I represent that one, say for example, you are having some container, means if you are adding, you are having some container. So in that container, what you have taken? You have taken the oil that I am going to represent with the help of a white color, say for example, and then if you are adding the water to it one, that I am representing with the help of a blue circles. Can you see this one? Can you differentiate now? Now here, so what? Water is added to the oil. I can say that these are nothing but the water. This is nothing but the water, and what we can see here is nothing but the oil. So that's why the one which is present in larger quantity is nothing but our dispersion medium, and the one which is present in the smaller quantity is nothing but the water. So as these two are immiscible with each other, so they will be mixed improperly here. Such type of solutions, colloidal solutions, are called as what? Emulsion. Okay, so this is one type. For this we can give the example of butter. For this you can give the example of butter. Butter is an example for what? Water in oil type. Likewise, you can have one more example, that is nothing but your what? Cream. Okay, so milk, cream, what you are going to get? No, that is also an example for what? So that is also an example for your water in oil type of emulsions. Okay, understood the first one? So if the water is dispersed in case of oil, such a type of emulsion is called as water in oil dispersion, or you can say emulsion. And here I have given the diagrammatic representation for that one. And then if you take the example for such a type of water, you can say the emulsions. So example is nothing but the butter and the cream. Okay na? So again you are having the second type. So second type is nothing but oil in water. Second type is oil in water. Okay, so how you can represent this one? Oil in water type, I can write here. Oil in water type. This is water in oil type, like that. So you can easily say now. So oil in water type means, so which is acting as a dispersion medium, or first if I write, so oil is dispersed. Oil is dispersed in water. Oil is dispersed in water. Okay, so here, so what about the oil? Oil acts as a dispersive phase and water acts as a what? Dispersion medium. In this type of what we can say, yes, I think you are getting, it is a very simple and easy concept. So what is that? So here in case of oil in water type, oil acts as a dispersion phase, and if you take the water, it acts as a dispersion medium, right? So then just if I represent this one, how you can represent, say if again there is some container, into that container oil in water, right? So oil in water. Okay, so the water should be in the larger amount, that I am representing with the help of a blue color. Okay, So here it is nothing but the oil. In that oil you can see that, so that is water. You can see that there is a presence of, there are the presence of this water. Okay, water droplets you can see here. So what we can say, the colorless are nothing but what? Oil, sorry. And here the blue color, what that is nothing but the what? You can say water. Okay, so water I have represented with the help of blue circles, and oil I have represented with the help of what? The white color circles. Okay, so which is the dispersive phase here? Phase is oil, medium is water, which is present in larger amount. Water will be there in the larger amount, and then oil will be in the smaller quantities, that we can say in the form of droplets here. Okay, so for this we can give the example of milk. We can have the example of milk, as well as some vanishing creams also. Some vanishing creams also you can give the example. So if you see the milk, no, sometimes you are going to see, if you boil that milk, if it is a thick milk and you are not added the water, large quantity of water to it, that one means, if you boil it properly, means you are going to see that there will be yellow color droplets, like you say that one has cream, or you can say that one has butter, like that. So that you can easily see. So that is nothing but what? Oil in water type. Oil in water type is an example for what? Milk. Milk, in case of milk, fat and water we can see. Fat acts as a oil and water acts as a dispersion medium there. So some in some year the question has been asked, what is that, what we can say, which is the dispersive phase and dispersion medium in case of milk. In case of milk, oil is the dispersive phase and water is the dispersion medium. That's how you have to write. Okay, so this is all about the definition of the emulsion and the types of emulsion, which are of two types. One is a water in oil type, and one more is nothing but the oil in water type. So if you take these two, out of these two, the second one, that is nothing but oil in water type. Okay, oil in water type is what? Little bit unstable. They are unstable. So then, in order to make them stabilize, we are going to add some reagents. Those reagents are called as the emulsifiers. What they are called as? Emulsifiers. What I am telling now? So that is the second type. What is that? Oil in water type. Oil in water type of emulsions are unstable. Okay, so they can be stabilized. By adding suitable reagents called as the what? We call those reagents as emulsifiers. What we called as emulsifiers. So what are these emulsifiers? So we can define them as the substances that are added. The substances. What are emulsifiers? The substances that are added to stabilize the emulsions. To stabilize the emulsions are called what? Emulsifiers, or you can say emulsifying reagents. Okay, so that process is called as emulsification. So this process is called as what? Emulsification. I think you are familiar with the term. So you are going to get this phenomenon. That is nothing but emulsification in case of your biology, right? Emulsification of fat by bile juice, or you can say that bile salts or bile pigments. So there you are going to see the emulsification of fats, because you know that fats are insoluble in water, but that's why the digestion is little bit difficult. Their digestion is little bit difficult. That needs emulsification before their digestion, before they will be assimilated by converting into simpler molecules. They should be first emulsified. So for that process is called as emulsification here. So what is how we can define this emulsification? The process of the process of stabilizing, the process of stabilizing the emulsions, the process of stabilizing the emulsions by adding suitable emulsifiers. By adding suitable emulsifiers is called as what? We call that one as emulsification. It's called as emulsification. Okay, so now there are different reagents which are used to emulsify the that is water in oil type of emulsion or else oil in water type of emulsion. So let us list out what are the reagents that we are going to add to emulsify. What is the meaning of that? We will stabilize, to be like oil in water or water in oil type interface should be there, then only we are going to get the what? Emulsions. So why we should stabilize? Because they are having very wide uses in our daily life. One of the best is nothing but the absorption of medicines that takes place mainly by the emulsifications, as well as we learn about the cleansing action of soap also, right? There also there is a formation of micelles. So that is also an example for your what? Emulsification. Okay, so let us discuss now. So what I said, so emulsifiers are nothing but the substances that are added to stabilize the emulsions, and here the process of stabilizing the emulsions by adding the emulsifiers is called as what? Emulsification. So let us see what are the reagents that we can use, or what are the emulsifying reagents for water in oil type, as well as what we can say second type, that is nothing but oil in water type. Right? I think you note down all these things. So here let us see the first one. So that is nothing but oil in water. Okay, for this one, oil in water type. What are the examples I have given? Milk and vanishing cream, I have given the examples. So what are the emulsifying reagents that we can add to be the oil and water in a phase, in interface to form the emulsion? So the reagents are, you can add the proteins. What we can add? Proteins we can use as the emulsifiers, or we can use the gums. Okay, so gums we can use as the emulsifiers, or you can use natural and synthetic soaps. Natural and synthetic soaps. So all these are nothing but the emulsifier, synthetic soaps. Emulsifiers that are used to stabilize the oil in water type of what? Emulsions. Oil in water type of emulsions can be stabilized by adding all these what? Emulsifying reagents. Okay, so likewise for what? Water in oil type, what are all the emulsifying reagents? So you can add heavy metal salts of fatty acids, heavy metal salts of fatty acids. Okay, again you can add the long chain alcohols. So long chain alcohols. Okay, so as well as lamp black can also be used as a emulsifying reagent for water in oil type of emulsion. So you just observe these two things. So that is nothing but oil in water type can be stabilized or emulsified by using these reagents. Similarly, water in oil type can be stabilized either by using heavy metal salts of fatty acids or long chain alcohols you can use, and also you can use the lamp black. Okay, so again, so if you come to the one more important concept, that is called as de-emulsification. Okay, so the name itself indicates de-emulsification means what? The breaking of emulsions into constituent reagents. So that is the reverse of emulsification. Okay, so you know that emulsification is stabilizing the emulsions by adding the suitable reagents. They should be in a interface. But here what you are doing in case of what? De-emulsification. Emulsification. Okay, so you are separating the two constituents of an emulsion. So two constituents of an emulsion by suitable methods. Okay, let us see. So that is the process of, what is de-emulsification? It is the process of separation of, or you can say breaking off also, you can write that one. The process of separation of constituent particles, constituents of emulsion, constituents of emulsions into two, because two constituents we can have. One will be the dispersive phase and one more will be the dispersion medium. If we separate those two by suitable methods, like you can employ the methods for this de-emulsifications, as you can have freezing. If you freeze them, they will separate into two constituents, or else you can use the what is that centrifugation. Okay, centrifugation method, and also you can use the boiling method also. If you boil also, you can separate the oil from the water, right? So chata chata anta aguttಲ್ವಾ, ಆಯಿಲ್ ಸ್ವಲ್ಪ ಏನಾದರೂ ನೀರಲ್ಲಿ ಬಿದ್ದಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಆರ್ ಎಲ್ಸ್ ಆಯಿಲಲ್ಲಿ ಸ್ವಲ್ಪ ನೀರಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಯು ಕ್ಯಾನ್ ಸಿ ದಟ್ ಒನ್, ರೈಟ್? ಸೊ ಒಗ್ಗರಣೆ ಎಲ್ಲ ಹಾಕಬೇಕಾದ್ರೆ ಈಗ ಅದರಲ್ಲಿ ನಾವು ಏನಾದರೂ ಮಸ್ಟರ್ಡ್ ಸೀಡ್ಸ್ ಅಂತವೆಲ್ಲ ಹಾಕಿದಾಗ ಅದರಲ್ಲಿ ಮಾಯ್ಶ್ಚರ್ ಕಂಟೆಂಟ್ ಇರುತ್ತಲ್ವಾ, ಸೊ ದೇ ವಿಲ್ separate. So like that, or else if you go for centrifugation, this you are going to do in case of clinical laboratories, like blood is also an example for colite, right? So if you take that blood and if you centrifuge that one, that will separate into serum and the plasma proteins. Plasma and the serum. So that plasma consists of the proteins, I think. So okay. So nowadays you know about RT-PCR test. They are going to bring some test tube like which is having a red color liquid. So what is that? That is nothing but the serum, right? That is separated from the blood, right? So that consists of antibodies. If you add the reagent or your sample to that one, that antigen, if they consist, they will react and they will coagulate, right? That is a different concept. Why I am taking that example here means how you got that serum. So when the blood is used subjected to centrifugation. So what is that centrifugation? That you are going to learn in higher classes. Very simple concept. If you take that one pipette like structure, it has been covered. If you centrifuge that one, so it will revolve at a very high speed. During that speed, what happens? The heavy particles will settle down and the lighter particles will come up, right? That's why the plasma protein will settle down and that one. So like that you can separate the constituents into two by the centrifugation, or if you simply freeze it one, you can see that oil will get separated, right? So likewise you can de-emulsify the emulsions. So what is the meaning of that? You can separate the constituent particles of the emulsions into two. Okay, so that can be done by any of this process. So emulsification is stabilizing, de-emulsification is destabilizing, or you are making unstable. Is that clear? If their constituent particles are together, then it is stable. If they are separated from one another, that is unstable. That can be done by de-emulsification. Is that clear? So different emulsifying reagents are used for the two types of the emulsions. So where we come across these emulsions? So I already said. So in the what you can say the drugs what we are going to use. So they are also the emulsions, like say for example, you can have your antiseptic lotions. If you go for the applications, of these emulsions, you can see the applications. The first one, the creams like you can say the antiseptics and disinfectants. Antiseptics and disinfectant, you know that these two are different things. So one is employed for the living tissues, that is nothing but the antiseptics, and one is employed for the non-living tissues, that is the inanimate surface you can say, okay, for the cleansing purposes. So they are also are nothing but our emulsions only. They are also emulsions. So suitable liquids or so you can have Dettol or you can have the Lysol for this one. So they are also what? Emulsions. They are mixture of two, any two, that may be oil in water or water in oil type, like that. Okay, so then you can have one more application of this emulsions, that is emulsification of fat. Emulsification of fat. So in case of living organisms, as I said, as the fats are water insoluble, they should be first emulsified. They will form into a micelle like structure. They will form the micelle like structure with the help of your bile juice pigments or bile salts. They help in the digestion of fat, right? They act as emulsifiers, natural emulsifiers they are, which are present inside. Okay, so that is the concept. As well as you can have the cleansing action of soap. Cleansing of soap. You already learned this one in detail. So, okay, cleansing action of what? You can say the soap. So, there I discussed about the soap. If it is entrapped with the oil or the grease, so it will connect by means of its hydrophobic end, and so that the hydrophilic end will be away from the globule, that is nothing but the grease or the that. What you call for this one? This is called as the micelle structure. So that is also an example for what? Our emulsions. So where we can see that oil in water type of emulsion you can have. Okay, so that helps in the cleansing action of soap also. So these are the some of the what you can say applications of what? Our emulsions. So finally, let us move on to the last concept of the chapter, that is nothing but the applications of colloids, or what we can say the colloids around us. What are the fields where we can apply these colloids? So there are so many fields. Some of them I already told while explaining some of the terms. Okay, so let us see what are those. You may get this question. So mention any two applications or any one applications they can give you and tell you to explain how it is, then you should know. Okay, so the first one I want to take about the so emulsification already over, right? So we are doing what? Applications of colloids. Applications of colloids. Applications of colloids. Okay, now, so what is this applications of colloid? Let us see the first one in the field of medicine. So there is a wide application of these colloids in the field of medicine. So the most of the medicines are colloidal in nature. Okay, so what we can say here, most of the medicines what we are going to use, most of the medicines are colloidal in nature. So you can have the syrups. Okay, best example, you can have the syrups that what you are going to use during the coughing or sneezing. So they will be colloidal in nature, right? So and you can have some of the example for this one, argyrol. There is one drug. So what is that? Argyrol, that can be used as a drug or that is nothing but an eye lotion, I can say. This is a eye lotion. So if you are having some disorders like redness of eye or some irritations in case of eyes, no, then we are going to apply some what you can say one lotion. What is that lotion? That lotion is nothing but the argyrol. Okay, so that is also a what? Colloid. Or else you can have the example of colloidal antimony. Colloidal antimony. Okay, colloidal antimony. Okay, so that is nothing but antimony. By taking this antimony, you can make a colloidal solution. So what is the use of this one? you can use in the treatment of a disease called as Kala Azar. Okay, leishmania, that is also called as leishmania disease, right? So that is fever and skin infection, finally death of the person also. That is spread through the insects from one animal to another animal, right? So that Kala Azar can be treated with the help of a colloidal solution, that is called as what? Colloidal antimony. Likewise, you can have one more example also, milk of magnesia, milk of magnesia, right? So that can be used as what? Antacid. That can be used as an antacid to cure the what? The stomach disorders. So if gastritis happens, no, because of the consumption of some acidic food or like that, the junk foods and all, you are come across the acidosis. In such cases, there will be burning sensation in the stomach and all. So then milk of magnesia can be given for that person. So that acts as what? Antacid. That is also one of the colloidal solutions. So these are all the uses of colloids in the field of medicine. Any one if you write, that is more than enough. Right. So likewise, you can have one more application of these colloids, that is nothing but in case of electrical precipitation. So where in case of electrical precipitation, which is very important here, precipitation, right? So what is this electrical precipitation? So you know that nowadays we are surrounded by means of so many pollutants. Those pollutants most of the pollutants are from the industries. Most of the pollutants are from the industries. Okay, so if they release so many types of exhaust gases into the atmosphere, right? So those gases consist of what? The poisonous gases like sulfur dioxide, carbon dioxide, nitrogen dioxide, like that. So okay, so if they mix with the air, means what they will cause? They will cause so many respiratory disorders. So before letting them, so the government has been order bring a rule that before letting the exhaust gases from the industry, they should be treated, so that we can minimize the pollution. So that can be done by using the electrical precipitator. So simply I will write a simple diagram for that one. So the structure will be like that, like this for the electrical precipitator, which is having an electrode, and here you are letting the exhaust gases that consists of poisonous gases, and here somewhere you are going to see that there will be outlet, so which consists of free gases. Okay, free gases, or you can say the gases which are minimized pollutants, which are having the minimized pollutants in them, right? So here you can see that the impurities, the poisonous substances, they will get precipitated and settle at the bottom, right? So this is called as control precipitator, or you can also call it as electrical precipitator. So here is nothing but the electrode, okay, nearly 30,000 volts of electrodes we are going to provide this one, potential difference, or you can say current of 30,000 volt is allowed through this electrode. So simply it is what? It is nothing but your electrophoresis only, where we can see that because the gases, they are nothing but what we can say, so they are nothing but solid in gas, aerosols. So these are the gases which are released from the industries, right? So when they are let into this control precipitator or electrical precipitator, what happens? So then a high voltage current is passed across the electrodes. So as these colloidal particles, or you can say the gases, they consist of what? The impurities, they are also charged. They will move to the opposite electrodes and get discharged and get settled down, right? So then, so the gas which come out, it will free from the poisonous gases, like, so that may be your sulfur dioxide, that may be what we can say that is carbon dioxide, or that may be what, nitrogen dioxide. So now this gas which coming out from this cuttle precipitator is free from the poisonous gases. So this is how you can minimize what, the impurities letting into the environment. So that's why again see here, you can see that colloids are very useful in case of what, what we can say, this is the application of one of the application of colloids. Okay, likewise you can have one more, that is nothing but, that is in case of tanning of leather. What is that? If I write here, tanning of leather. Okay, so we are having one more, that is called as tanning of leather. So second one I wrote down. So that is electrical precipitation. Electrical precipitation. The third one is nothing but the tanning of leather. Okay, so tanning of leather. So you know that. So leather. So it is usually it is from what? Animal hides. So leather is nothing but the animal hide. Animal, what we can say, hides. So that is from the skin of the animals we are going to prepare the leather, what we can say, the items. So like that may be your belts, that may be the shoes, that may be the vanity bags what you carry, that may be the waistcoats what you wear, that may be the belt of the watches what you are having. You all are very fond of leather items. Right. So how those leather items are prepared? So they are prepared from the animal hide. But if you look at the animal skin, that will be very smooth in nature. Then how it has been converted into that much hard? If I observe this watch also, right, how it has been become that much hard? So that is mainly because of one process that is called as tanning of leather. What actually happens there? So this animal hide, it is actually positively charged colloid. Animal hide is a positively charged colloid. Okay, so when it is added to a chemical that is called as tannin, so which is negatively charged, what happens? Precipitation takes place, or you can say mutual coagulation takes place. So when you mix these two, what happens? Mutual coagulation takes place. Right, mutual coagulation takes place, that leads to the formation of a leather which is hard, that leads to the hardening of leather, So that process is called as what? That process is called as the tanning of leather, where two oppositely charged colloids are mixed with each other, leads to the mutual coagulation. Finally, hardening of leather. This is one more application of colloids, right? So again you are having one more, that is nothing but rubber latex. So rubber latex. So you know that rubber latex, it is obtained from the plants. That is also an example for colloids. So what you know about the use of rubber? So you are going to use a rubber in various fields, right? You are going to use the rubbers in the various fields. So there you can see that the rubber latex can be obtained, so by the coagulation of latex. So that is nothing but a colloid. Rubber latex is a colloid. Okay, obtained from rubber plants. Colloid from rubber plants. Right, so that can also be, if you have seen the rubber latex, means that will be what, sticky in nature. That is nothing but the colloids. How that can be precipitated? By adding the sulfur. What do you call for that one? Vulcanization of rubber. So that is also again an example for our colloid. So also you can have one more example, that is the photographic films. One more application, photographic films. Okay, so they are lined, or they are prepared by coating emulsion of light sensitive AGBR. How these photographic films are prepared? By coating light By coating light what? Sensitive silver bromide solution, by coating silver bromide in gelatin. This is nothing but an emulsion. Silver bromide in gelatin is an emulsion. So that is coated to what? Photographic films, and which is very useful in taking the photographs or in developing the image of an person. Okay. So likewise we can have some other examples also. We can just write down here. So that is the products like industrial products. What we are going to use, like your paints. Okay, that may be paint or ink, what we are going to use, the paints, ink, okay, synthetic and plastic, synthetic rubber. One more is synthetic rubber, okay, are you getting the concept? Synthetic rubber, and also graphite lubricants, okay, graphite lubricants. All these are what? Synthetic lubricants, cement, what you are going to use, right? If you add the water to the cement, that will become a collide also. All these industrial products are also example for our what? Collide. And also I can join this one also, finally delta. So what is delta? Actually that is a region where the river meets the sea. That region is called as the delta. There also you can see that, you know that sea consists of dissolves calcium and magnesium ions, because that is hard in nature, right? So if you take river water that is having water, negatively charged ions, that leads to the formation of what? Delta. That is also an example for what, or that is also an application of colloids. So this is how you can say all these are what? Applications of colloids, where we can see that the colloids are very, very useful in our day-to-day lives. So we are going to use them in the medical field. They are also used in case of what we can say, that is nothing but the electrical precipitators, in order to treat the industrial gases which are poisonous in nature. And then they are also used in case of tanning of leather, because leather will be very smooth. See here, you have to remember again, animal hide is positively charged, and the tannin what you are going to add for that one, that will be what? That will be negatively charged. So their mutual coagulation takes place. That is likewise you can have the rubber latex, or else the photographic films, that is lined by AGBR in gelatin emulsion, as well as these are the industrial products. And also I told about the what? Delta. And also you can quote this one also, the dust or the formation of dust, smoke, right? Also the foams or the fogs in the morning, they are also example for what? Our colloids. So that's why colloids are very, very useful. So at the end I can say that in case of surface chemistry, we learned in detail about what we can say the adsorption, that is the first concept, right? So there you have to remember the thermodynamic concepts, that is during adsorption, that is a change in the internal energy, that is delta G, as well as enthalpy as well as entropy, all are negative. That is a very important concept. And theory of that adsorption, how adsorption actually takes place, right? And characteristics. Next we learn about the catalysis. So there in the catalysis you have to learn about heterogeneous and homogeneous catalysis and the example for both, and how this heterogeneous catalysis is very useful in case of industries, right? So again we learn about the enzymes. They are nothing but the biocatalysts and their characteristics and their also their mechanism. And then we that is all about the catalysis and their application. Finally we come to the colloids. That is also one more very, very important. So if you go for theoretical concepts, you have to learn the differences between lyophobic and lyophilic salts, and then one more is differences between physisorption and chemisorption, right? So again you have to learn about the characteristics of a catalysis, right? And the classification of colloids and all. Okay, so in the next class we are going to discuss some of the questions related to this surface chemistry chapter. Okay, thank you.